Well, the wait is over. We are talking about the unit circle. So 8.3 is the unit circle. It would be nice to know where you guys are at with this. I have no idea if you've seen this or not. But we are starting with the unit circle and radians. So what a radians is just a unit of angle measurement. So you guys are used to degrees. So if you look closely on here, it does give you all of the degrees that you have seen before. So you know, like this is a 90 degrees, this is 180, and like the 360. But we are going to be working with radians now. Radians is just if you have your circle, and so that's like your 0. If this is your radians right here, this would be like a radians too. Okay, so if you were to place whatever your radians is and you place it here and you keep going all the way around, it'll be about 6.28. So I can fit 1, 2, 3, 4, 5, 6, and then a little bit extra. Or what this is 2 pi. Okay, so if you're looking over here at the unit circle, if I go from 0 to 180, that is pi. If I go all the way around again, this would be 2 pi. So I would write that underneath there too. So it has the 0 there. I'd also write the 2 pi. Okay. So something that I want you guys to start realizing with the radian or the unit circle is, first thing is it has a radius of 1. So if you look here, we have 1. If you are looking at a coordinate plane, so if I have a coordinate plane and you go over here, this would be the point 1, 0, because I move over 1, I don't go up or down. Well, if you look, 1, 0. If I go up here, this would be the point 0, 1, because I'm not moving left or right at all, and I'm moving up 1, well, 0, 1. Okay, same idea if I move a -1, 0, and then 0, -1. Okay, so my radius is a 1. Another thing that I want you to notice then is every single one, so it starts off 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. So I'm looking at that denominator. It follows a pattern. Like I said in your last lesson, you guys, if you were in class, you'd have to be memorizing this. Consider yourself lucky you got out of it this year. I do know though next year you will have to have this memorized. So I want you guys to start seeing these patterns. These things in your parentheses. So this is the cosine, and then this is your sine. Okay, so the cosine √3/2 does show up again over here for the sine, √3/2. The 1/2 and the 1/2, they kind of just are flipping. Square root of 2, square root of 2 over 2, those are the same. It's going to be the same for all of the ones that are over 4. So they're always the same. The 4, the same. Okay. The 6's, if you look at the 6, my cosine, so what I mean by 6, if you look at the denominators of the 6's, my cosine is always going to be √3/2, √3/2, √3/2, √3/2. Okay. Same thing with the 3's. The cosines will be the same, and then the sines will be the same. Okay, so those are patterns that you should start seeing. The 6's are always the closest to your horizontal line, and then the 3's are close to your vertical line, or the y-intercept. What else is there? Yeah, I think that's probably the biggest thing. Other thing that I do want you to see is all students take calc. Okay, so if you're memorizing this, what this means is all of them are going to be positive. So if you, actually I want to talk about tangent first. So what tangent is, it equals sine divided by cosine. So I would take my sine, so 1/2 divided by cosine. So 1/2 divided by √3/2 would give me √3/3. root 2 over 2 divided by root 2 over 2 would be 1. Root 3 over 2 divided by 1/2 is root 3. Okay. Sine 1 divided by 0 is undefined because you can't divide by 0. I'll just go quick through these. This one, because I do have a negative, it's going to be negative root 3. Same idea, I'm going to have a negative 1 and then negative root 3 over 3. Okay, then this one's going to be, since I have two negatives, it's going to be root 3 over 3. I have two negatives, so it's going to be a positive 1. I have two negatives, so it would be a positive root 3. This one would be negative because I do have a negative, so root 3, negative 1, negative root 3 over 3. Okay, once again, it is a pattern, so these are my closest. These are the closest to the vertical. These are the closest to the horizontal. Okay, so with this all student take calc, all of them are going to be positive. So my sine's positive, my cosine's positive, and my tangent for all of them. My sine is going to be the only positive. So if you look, my tangent's negative, my cosine's negative, but my sine is positive. Negative, negative, sine is positive. Negative, negative, sine is positive. Okay, this one, my tangent is going to be positive. Everything else is negative. So tangent's the positive, everything else is negative. C, my cosine is going to be the only positive. So cosine's positive, the other two are negative. Okay, so if you want to make a little note up here, all students take calc. Okay, so all students take calc. Okay, so like I said, tangent is sine over cosine. If you are going one time around, so you're making one rotation, we'll write one rotation, that's probably a better vocab. It is either going to be 360 degrees or 2 pi. Okay, so you need to be familiar, I know you guys are familiar with the degrees, but we need to start getting used to radians. Okay, and like I said, my cosine and then sine. So this is my x and this is my y. Okay, so we are then going to talk about converting angles measures to degrees to radians and then radians to degrees. Okay, so with my degrees to radians, so this means if I'm trying to get from like 150, how do I figure out what the radians would be? So you're going to take whatever number they give you in the degrees. So this is going to be a degree, and you are going to multiply it by pi over 180 degrees. Okay. Key thing when you do this, you're going to keep the pi kind of out of the equation, then you're going to add that in at the end. We'll get to an example of that, so you'll see what I mean. Alright, so then for the radians, we are going to take whatever radians they give us, so that means it's going to have a pi possibly in it. And we're going to multiply this by 180 degrees divided by pi. Okay. Let's see. We will actually stop here. I know it's kind of a quicker lesson, but I think it's a good stopping point, and then we'll start off with example 1 tomorrow.